Mm. Hello, my name is Inigo Montoya. You killed my father. Prepare to die. You shall not pass!
Hi guys. So I don't know about you guys, but we've watched a lot of TV and movies in recent weeks. And my friends Inigo Montoya and Gandalf the Grey and I have noticed that oftentimes when we sit down as a family and we start to watch a comedy, we often finish it, go to bed at a decent time. We watch it in one sitting. But sometimes when we're watching a drama, a dramatic feature, we often have to pause it, maybe watch an hour, pause it, come back and watch some more the next day. So that kind of got me thinking and wondering, do comedies versus dramas, do they have a different runtime? The runtime of a movie is the length of a movie in minutes. So I decided to gather some data and find out. You guys might also be watching some comedies like Princess Bride, some dramas like Lord of the Rings. Do they have different runtimes? So we're going to get ourselves set up here to move on with this week's first lesson, which is about comparing data. So first of all, let's make sure we are set up correctly in our notebook. So on this page here, here's our table of contents. This is what you should have if you're all caught up from week 1. So to move on here to week number 2, I'm just gonna skip a space here to keep myself organized. And I'm gonna start week number 2's information here. And I'm going to call this page, this first page we're working on for week number 2, comparing 2 sets of data. And I decided just, since I'd already gathered the data for you, also I'm gonna put page number 7 here. So I've got comparing 2 sets of data there. This is to start me off for week number 2 and where I'm gonna keep track of everything for week number 2. So I should already have pages 1 through 6 all filled out. So right now I am flipping to page 7, again, to make sure we got this set up correctly. So here's my table of contents. I got that filled in. I flip over to page 7, label it as page 7. And I actually already wrote down my data here. So let me tell you what we have on this page. And while I'm talking, you can write this down, or if you need to pause it to get it written down, you can. I got my title up here, comparing 2 sets of data. And I was focused on 2 populations here. I was focused on comedies, things that are generally labeled as a comedy, funny type movies, versus dramas, dramatic movies, more intense, okay? And so what I did actually, because there are lots of comedies, lots of dramas, and some that even cross over a little bit. So what I decided to do to get a sample is I just looked up, because a lot of us are watching these movies on Netflix. I found a couple lists online of like the top 20 comedies on Netflix, and that list also included their runtime. And I just picked, just for the ease of not having too huge of a sample for us to work with, I just picked the first 12, and I actually already put the data in order for you. So this list right here tells me of those top 12 that these particular lists said were the best comedies to watch on Netflix right now. This is their runtime. And I put them in order. This isn't the order they were in the top 12 list, but this means that there were 3 of them that were 85 minutes long, 3 of them that were 92 minutes long, etc. Okay, so this was the top 12 comedies on Netflix. Then I did another quick little search. The internet is full of interesting data. I did another quick little search, and I found a very similar list of the top 20 dramas on Netflix. And I just took the first 12 on the list, so I just used the top 12, and then I put that data in order. Now, it's already starting to look like some numerical patterns coming into play here. I'm starting to notice some things. But when we compare data, so last week we just focused on 1 set at a time. I'm going to look at this 1 set and I'm going to get the measures of center, or I'm going to get the measures of variation. And that definitely tells you some things about that 1 set. We are now looking at 2 sets. And this is really where that information gets more interesting for us. And I think that box plots are often the most useful data across the board. The box plots will give you a really good breakdown of everything that's happening in that data set. So what that means is I am going to go through these and I am going to find my 5-number summary for each of these. So hopefully at this point you've got this title on here and you've copied all of this down. Again, if you need to pause the video to finish that, please do. But you should have that data written down on page 7. So as long as you have that, let's go through and I'm going to start marking up the data. So I'm going to start with sample 1, which is comedies. And I am going to start marking things. I remember my 5 number set. I'm going to come down here. I'm going to skip a space here and I'm going to write comedies. I need my 5 number summary, which means I need the min. I need the lower quartile, which is Q1. I need the median. I need the upper quartile, which is Q3. And I need the max. So I am now going to come back up to my list here and I'm going to find those things. I told you I used the top 12. Well, 12 is even and half of 12 is 6. So my median is going to come 1, 2, 3, 4, 5, 6 right here. And then just because I always do, I'm going to check over here. 1, 2, 3, 4, 5, 6. There's 6 on each side. That means my median is halfway between 92 and 95. So you can either kind of just visualize where that would be, or you can type in your calculator 92 plus 95 and then take that sum and divide by 2. I already did that, but you could type it in your calculator, make sure you know how to get it. The median is 93.5. That's halfway between 92 and 95. So there's the median. Now, remember the lower quartile and the upper quartile is just finding the median of the lower half, which is now 6 numbers. So I'm going to go 1, 2, 3. There's the middle, 1, 2, 3. And then I'm going to get the upper quartile while I'm at it, 1, 2, 3. There's the middle, 1, 2, 3. All right, quartile 1, halfway between 85 and 92 is 88.5. If you're unsure about where that came from, you can do 85 plus 92 divided by 2. Likewise here, halfway between 100 and 102 is 101. Now the only other thing I need for this comedy information is I need the minimum, which is 85, and I need the maximum, which is 106. That is going to help me get a visual, a box plot, in just a second. First, I need to get similar information. I need to do the same thing for the dramas. So there's my comedies 5 number summary. Now I'm going to come over here and I'm just going to use a different color for dramas. But I'm going to get the same information. I'm going to get the min. I'm going to get the lower quartile. I'm going to get the median. I'm going to get the upper quartile. And I'm going to get the max. So let's try this again. There's 12 pieces of data here as well. So 1, 2, 3, 4, 5, 6. There's the middle, 1, 2, 3, 4, 5, 6. The median, halfway between, if I do 118 plus 123 and then divide that sum by 2, really what you're doing is finding the mean or the average of those two. That's 120.5. The middle down here, here's the lower quartile. See, 1, 2, 3, middle, 1, 2, 3. I do that again here, 1, 2, 3, middle, 1, 2, 3. That halfway between 111 and 116 is 113.5. Halfway between 136 and 140 is 138. Then I just need my minimum, 104, and my maximum, 159. All right, so I have now taken the list of these runtime. Again, this is all minutes. All of this is being measured in minutes, and we'll put that label on a box plot. So here's what happens when you actually compare 2 sets of data is we're going to do stacked box plots, because that's the only way you can compare, and you can only make a real accurate comparison if all of this is actually on the same number line. So that means I need to make sure my number line can fit everything in both of these sets. So I need to make sure I have this lowest, 85 is the min here, 104, so this one's lower. I need to make sure my number line goes all the way from 85 to 159. I need to make sure all of this can fit on one number line. Now, since I also know I'm going to stack the box plots, I'm going to count some spaces and draw the number line a little lower. You ready? So starting with this space, I'm going to go 1, 2, 3, 4, 5. So I skipped 5 spaces, and then I'm going to draw my number line underneath that 5th space. So make sure you got this formatted correctly so that you know you have enough room to do what you need to do. So this is my number line. You could even use a ruler if you want it to be nice and straight. But I know that this number line needs to go all the way from 85 to 159. So what if I go by, I'm going to extend this a little over here, and I'm going to put a scale marking here. And I'm gonna start maybe with 80. I know nothing goes down to 80, but I wanna count by tens because I feel like tens is gonna get me where I need to. So 1, 2, 3, 4, 5, 6, 7, I'll need like 8 to get from 80 to 160 if I'm counting by 10. So I'm gonna try and evenly space them and then I'll come back and label them. So here's 80. I'm just gonna count out loud while I draw it. And that helps me make sure I'm not missing anything. So I'm counting by 10. So 80, 90, 100, 110, 120, 130, 140, 150, 160. And I tried to kind of make them evenly spaced. It doesn't have to be perfect, but these are all 10 apart. So you do want to show that visually by trying to make them evenly spaced. So now I'm just going back and labeling these. 130, make sure you get all this labeled. All the way up to 160. And then I'm going to put a label down here too that tells me these values represent the runtime of the movie in minutes. That's what runtime means. So just so you can kind of put this together and understand, remember an hour is 60 minutes. So that means none of these movies were less than an hour because the lowest we have is 85, which would be 60 plus 25 minutes, an hour and 25 minutes. This 120-minute mark is 2 hours. And 180 minutes would be 3 hours. So none of them on my list went that far, but certainly there are movies. There are movies, huh, Gandalf, that go to that 3-hour mark. All right, so let's draw these box plots. Let's take this information. Now I need to stack this and I need to put, so I'm gonna start with the comedies information and I'm going to put that, I'm going to skip this space and I'm gonna start marking things in the middle of this second space. So here I go. The minimum value is 85. That's going to be halfway between 80 and 90. So I'm like, okay, here. I'm not writing anything yet. I'm just kind of getting my distance. So I'm going to come up here and I'm going to put the little bottom whisker right there. That represents 85. Lower quartile is 88.5. Now I'm kind of eyeballing this. 88.5 is not quite 90. I know this is going to be the bottom part of my box, so I'm going to let that fill the whole space. The median is 93.5. Well, 95 would be here, so I'm a little less than that. So the median's about down there. The upper quartile is 101. Well, here's 100, so 101 will be just past that. And I'm ready to draw my box here. There's my box, there's my lower whisker. And the maximum is 106. So 105 would be here, 106 is a little farther than that. So this box plot right here, I need a label on it because now I'm making a comparison. So I'm going to come over here, I'm going to tell myself that this pink one represents the comedies. That box plot is comedies. Now, if you just looked at that by itself, you might wonder why I have this big old thing, because this is just this cute little box plot over here. And you'll see as we make comparisons why it's then important that we put them on the same number line. It wouldn't really be a very good comparison if they weren't actually on the same number line. So what I'm going to do now, and this can get a little tricky. I actually oftentimes like to put my other box plot below because then I'm still close to the number line and can see what I'm doing. But it's more common that you'll see box plots just stacked on top of each other. So I'm going to show it to you that way. So the dramas now, the minimum is 104. So I'm going to come on my number line here. I know 105 would be halfway between. So 104 is going to be a little less than that. And I'm going to come up and I'm going to skip this and jump all the way up to this space here. So 105 would have been halfway. 104 is just going to be a little less than that. That tells me that's where my lower whisker is going to be for dramas. Already that very bottom whisker is higher than most of the entire comedies box plot. So quartile 1 is 113.5. So 115 would be here. We're going to be a little less than that. That's going to be the lower quartile. The median is 120.5. We're just going to be a tiny bit past 120. The third quartile is 138. So that's going to take us pretty close to 140. And look at that. I've got my box. Remember, you can pause this video at any point, rewind things if you kind of missed how I drew it. There's my lower whisker. And the max takes me all the way up to almost that last scale marking, 159. Now, this one I'm going to label as dramas with orange here. And right away, I noticed some things. And this was already kind of my prediction before I started this, based on my personal experience watching comedies versus watching dramas. I had a prediction, I had a thought that probably dramas were longer because you seem to need to pause them and come back to finish them. So when I look here, though, this gives me nice, solid statistical evidence to support that and to make more official conclusions about this. It's very clear to me, first of all, that the drama's box plot, all those values in the 5-number summary, every single one of them is higher. The minimum's higher, the lower quartile's higher, the median's higher, the maximum's higher, everything is higher. So the purpose of doing this, what we're ready to do now is we're ready to come down here on the bottom of our page. And the last thing we're going to write here is we're going to use this great data that we got right here to make some conclusions. We're going to say, okay, what's some stuff that I can now say with a little bit more statistical evidence is true? Some conclusions about this data. So there's quite a few things we could say. I'm going to give you a list of 4 or 5 of them. Okay. One conclusion I could definitely make is that in general, dramas have a longer runtime. That is just so clear from these plots. Dramas are just longer movies. They just are. And I can see that really clearly from these plots. So dramas have a longer runtime. Now, something else that's always really important, and this is one of the most useful things about a box plot, is it shows you, as we talked about, it shows you the variability. In other words, how is it spread out? Not only are dramas a lot higher, but I see that this whole comedies box plot is really small, and this dramas plot is a lot longer. That tells me that drama runtimes have more variability, which is also known as the spread. So it's more variability or more spread in the data. The data is just literally more spread out. Now, that means that the variability is what kind of allowance is made there. You could have a drama that's a little shorter, like a comedy. You could have a drama that's only 100 and so minutes, but it's also, it seems acceptable to have a drama that's almost 3 hours long, okay? Where with something like a comedy, the comedy run times, so I'm gonna put this statement, the comedy run times are more consistent. That means they have less spread, less variability. So I'm going to say less spread. And I would imagine that there are kind of accepted things here when there's a director that's like, hey, I want to make a movie. You have to decide, is this going to be a drama? Is this going to be a comedy? Because maybe the plot lines of a comedy aren't really always the focus. And maybe it's just like, hey, let's make people laugh. And maybe you can't get away with that for 3 hours. Maybe that has to be a drama with a much deeper plot line and a much deeper story that you're more engaged in for that long. I don't know if you can stay engaged in a comedy for 3 hours. So these time frames are much more consistent. The fact that that box plot is so small tells me that comedies all kind of have a similar runtime. And just a couple more statements, just because this part of the box plot is always really, really important. That middle 50%, which is the box, right? So 50% of dramas, and this is an important comparison to make, as you can look at that middle 50%. And this is the last couple things we're going to write down here. 50% of the dramas are between, and that's our box here, which came from Q1 and Q3. So I can see the bottom of the box is that 113.5 and the top of the box is that 138. So 50% of dramas are between 113.5 and 138 minutes long. That's what runtime means. So we can safely say that about half of the dramas are between that time frame. And one more statement, we can make a similar statement for comedies. This is a good comparison. 50% of comedies are between, so that was 88.5 and 101 minutes long. And that middle 50%, in other words, the IQR, remember that's what these are. Let's go back and add that. That's talking about the IQR. That size of the box, once again, tells me that comedies have a smaller spread, less variability in that middle 50%. It also tells me that comedies are shorter, dramas are longer. So really the power of box plots and measures of variability and finding all this information is when you start actually making comparisons. And so you guys are going to, we created the box plots here. You're just gonna do one more MLE after this where I gave you a bunch of box plots that are already made and you answer some questions about them just to make sure you're getting the idea of comparisons. And then the rest of this week, you guys are going to actually work on gathering some of your own data and putting together a little project of comparison. So start thinking about what kind of data would you be interested in? And after you try the MLE, the next thing you'll do is a sample project with me. And that will actually be your assessment this week. So be thinking about what 2 sets of data, what kind of data would I be interested in comparing, and then try the MLE and then work on the sample project so that you know more what that's gonna look like. All right, bye guys.